Alright, so let's work a couple of molarity problems. So the first question that we got here says, what is the molarity of a solution made by dissolving 808 milligrams of potassium phosphate in a total of 300 milliliters of solution? So actually the first thing we need to do is let's go ahead and convert milliliters to liters here so we know what the volume is. So that's pretty simple. We've got 300 milliliters, and to convert that to liters, because remember molar is equal to moles over liters. Okay, so we're going to do that first. Alright, so 300 milliliters, and we just use our handy-dandy conversion thing here, and that's 1 liter divided by 1,000 milliliters, and that's going to give us 0.300 liters. So that's the volume we're working with. Okay, so now we're going to take our 808 milligrams. Okay, so I'll kind of draw a line there. Alright, so now we're going to take our 808 milligrams of potassium phosphate, and we're going to convert that to grams, and that's similar to converting to liters. It's going to be 1 gram over 1,000 milligrams. Alright, so that'll give us now our mass of K3, PO4, potassium phosphate, K3PO4. So now that'll give us the grams of that stuff. So now we're going to multiply that times the conversion factor to get to moles, and that's going to be 1 mole in the numerator, and the molar mass of potassium phosphate, which is 212.27 grams of potassium phosphate. I'll try that again. K3PO4 is the formula. Okay, so then that will tell us how many moles of this stuff we have, the moles of potassium phosphate, and then okay, so we'll go ahead. Yeah, we'll go ahead now, and so that'll be the moles of potassium phosphate. That's right here, and we need to divide that by the volume. Okay, now we've already figured out that the volume is actually 0.3. So all we need to do is to divide this now by the volume to get moles per liter, and that's going to be 0.300 liters. And when we run all those numbers, we'll get an answer of 0.0126 moles per liter, which is the same thing as moles, or molar, I'm sorry. So the molarity is actually 0.0126 molar. Okay? So that's the first one. Now, another type of problem that you should know how to do is one that asks you how to make up a certain kind of solution. And in this case, it's asking us to make up a certain volume of a 0.056 molar solution of barium nitrate. Okay, so this is pretty easy. If we multiply the moles per liter, which is here, the molar, by the liters over here, we're going to convert this to liters. That'll actually give us the number of moles, and then all we have to do is convert to grams. So let's do that. Let's actually start off with the volume here. Now, just like we converted the 300 milliliters up here, we're going to convert this to liters. So I'm not going to show you the math, but it's just going to be 0.750 liters, and we're going to multiply that by the molarity. I'm not sure what happened to that there. Huh. It's kind of weird. Let's see if I can get, yeah, there we go, shake it up. So the molarity there is 0.0560. I'm going to go ahead and say moles per liter, so you can see that the liters are going to cancel out here. Okay. Um, okay, so then the only thing I have left, that's going to give me the number of moles of barium nitrate that I need. So now I just need to multiply by the molar mass of barium nitrate to get my answer. And that's the molar mass is 261.37 grams of BaNO3 taken twice, and that will be for 1 mole. So now the moles are going to cancel out, and I'll be left with just grams, which is what I want. And my answer is going to be right at 11.0 grams of barium nitrate. So hopefully you know how to do those numbers. I emailed you this exact thing on hard copy if you don't want to watch the video again. But hopefully that'll show you how you both figure out what the molarity of a solution is, and also how to make up a solution if you need to make up a solution of a certain molarity. So those are two problems that you really ought to know how to do. Good luck studying.